earlier, we put two questions up, and that's mostly reflecting my bias, as I am most interested as a sort of the outcome of today's discussions and this particular panel in thinking about the research needs and understanding that there's not an abundance of resources. How can we look at plans for existing studies and possibly incorporate looking at the data or collecting information in a way that can inform these two questions. One, focusing on the critical life stage, as Linda brought up, exactly what are the most relevant windows that we need to look at in terms of early life exposures. And you all had conversations on the phone about what does early even mean. And then the second question is, what can we do with the design of studies to at least begin to collect the right type of information to probe and answer these questions? So I think, Anna, we'll start with you and then work back this way.
Okay, so I'll start a little bit with the question about the designs. And first of all, I would like to say that it's been such an exciting day. And I feel like somebody like me who works in academia, I do environmental epidemiology. Today is like a day to get so many ideas in terms of thinking the types of innovative research that we need to do in the next few years, and maybe probably even more than a few years, for a long while. And it was a great place to be to get all of these ideas. As an epidemiologist, of course, we have all our traditional designs and the prospective cohort, as we saw from Margaret. Today, it's going to be essential, the samples that we need to collect and how to do this. It's been covered, I believe, pretty well. I was thinking about other cohorts that are also very interesting, these family cohort studies, with the potential to look at this phenomenon of how are families similar or different in their microbiome. How, if you have large enough families, can you look at actually at this loss of diversity, or how is it tracking over time? And also, of course, families' designs were mostly developed in genetics. So how this genetic microbiome interaction and conversation is happening. So I think this family cohort design could be extremely useful. And but I was thinking also, and some of that has been covered a little bit, is in addition to the traditional observational designs, we have a real opportunity for using these natural experiments in our advantage. And of course, the best natural experiment that we can think of is the antibiotic use. Can we really do designs around that antibiotic use to understand especially the metabolism of environmental chemicals? Can we look at before and after? How can we do these types of things? I think it will help us a lot to understand internal dose and excretion pathways and others, and then potentially also maybe to health effects, but especially to understand the metabolism and antibiotic use, but also many other things like bariatric surgery that now is going on, and even this fecal transplant. There was this paper in JAMA this week about this trial to look at fecal transplant for Clostridium difficile colitis, and so I was thinking if we could partner with those people doing this type of interventions, that would be such a collaborative and advantageous situation. So I was thinking these natural experiments, and of course the clinical trials. I think it's a unique advantage. In our environmental health world, we are not so used to clinical trials, but I think in this case, they provide a real opportunity. First, through the microbiome manipulations, as Maria Gloria was doing and showing us what an easier clinical trial could be and how much could we learn from that. But the other type of trial is also to look at this issue of potential mediation. We are doing so many trials to look at dietary interventions and physical activity interventions, and many, of course, antibiotics in clinical trials. So could we also take advantage of those ongoing opportunities to look at the impact through randomized designs on the microbiome, and then maybe trying to look at mediation with other health endpoints. I was thinking when we look at the dietary intervention trial that was shown from Israel, that was so interesting. I was also thinking about all of these DASH trials with the DASH diet. And could that actually play a role in improving blood pressure control? And unfortunately, we never collected those samples. So, but there are other trials going on right now that we need to think about those. And so that was in terms of this diet. And then I was also thinking ecologically, because we've heard about the built environment. And suddenly I was thinking about this sewage epidemiology. And I don't know if you've heard of that term, but it's in Europe, it's been used. There are a couple of papers. And I know Rolf Halden from Arizona State University has developed that. I remember him talking, and it's more like ecological, but can we really collect all this waste water? That was also mentioned at one talk today earlier, and learn about microorganisms, learn about chemicals. There is so much that we could do that could be useful, especially I think for surveillance and for having the changes over time. I think that could be an additional, more ecological type of epidemiological designs that could be useful. So that's in terms of the designs. And in terms of the age, I think we've talked so much about the early life that I would like to also talk a little bit about the aging and this interaction between the host and the microbiome, and how is aging affecting the microbiome? We know that I think I read that it's pretty constant during adult life, but after 65, it starts to change quite a bit again. So how is that communication going? So that this conversation is affecting the aging, the healthy aging of the microbiome versus maybe not so healthy aging, and how that could impact disease. We know that our major diseases, cardiovascular disease, cancer, they all increase dramatically with age, especially after 65. So again, that's another opportunity for thinking and working on. So that's kind of my summary of my thoughts.
Gloria, you're next.
Yes, I have three ideas here. One is, how early do we need to go? How early is early enough? Do we need to ask the mothers, were you born by C-section yourself? Was your mother born by C-section? What about your grandmother? And so on, all the impacts. Did you have antibiotics? Did your mom have antibiotics? It seems to me that if it's generational, we should try to find a way to measure how impacted the microbiome of a child might be through trying to investigate about the sources. The second one is to consider that humans have co-evolved with microbes that are not allowed today to exist in the intestine, eukaryotes. So we still think of parasites as parasites, and actually we call them parasites. Mostly for people who work in third world countries, they are bystanders that have no manifestation. Most people are asymptomatic. So of course, when there is an imbalance and there is an infection, ascariasis or helminthiasis in general, people recognize that that's caused by the parasites, and then we try to kill them and eliminate them. But the reality is that most of the healthy people living in tribal societies are happily living with their 7, 8, who knows how many we are trying to find out, eukaryotic helminths and protozoa. What's the role? How do they change the microbiome? We have no idea. The third one is the metabolomic, to think that any impact translates into a different chemical status in the body. And so what are the, at the metabolic level, what are the metabolites that are crucial and when? We have no idea about the metabolites. And finally, in relation to aging, the problem is, as Marty's experiments show, there is one point when microbiomes may bounce back, but phenotypes don't. So how informative are late microbiomes? It seems to be that we have a short window to investigate, because then things seem normal. We cannot investigate through the microbiome because that phenotype disappear, that status disappear, but there is a permanent consequence on the phenotype that does not bounce back. Those are my four grains.
Good afternoon. We're talking early. I'm wondering why we're presenting so late. That's just to wake you up. I think I really just want to underscore the many design options that the two previous speakers have offered, which is, I think, really exciting, and dependent on what research question we want to formulate for what part of this answer, putting the microbiome together with the environment, it just means we're going to have a lot of great options. And as an eternal optimist and somebody who is always interested in trying to take advantage of the unique population subgroups to help answer questions, I'd like to add and underscore to the prospective cohort design, the research, to think about looking at multiples, twins, which present an incredible opportunity to look at possibly a shortened gestation, perhaps more medication use. Most of them are going to be unlike sex. And so that's sort of like almost a natural experiment to try to look at the vulnerability of sex, male versus female SIB pairs in utero, for example. Also thinking about one of the best things that we know about future pregnancy outcomes for women is what she's done in the past. And most women, including those in the U.S., still have, on average, 1.7 children, or pregnancies, or children, that is. So most women will have a second pregnancy. And it could be an opportunity to think about the natural history of the maternal microbiome from one pregnancy to another to help inform what might impact the progression of the transfer of the maternal to the infant biome and what happens in that next 3 years. I really like the idea of also looking at very vulnerable children, preemies, for example, or children who are in NICUs, who not only get the chemical exposure, but also are getting a great deal of medications. One of the things that has really troubled and excited me today is some of the work that you were presenting, Marty, actually looking on a single exposure of, for example, of antibiotic. And I think when you try to publish measurement of an exposure, let's say of something very short-lived, at one point in time for, sort of an outcome a little bit later, nobody wants to believe that a single exposure could ever do such a thing. And so it also makes me think about paracetamol exposure and some of the concern that we're talking about here too. And I think that the reproductive age population, men and women, those of you who know me will know I always think about males. We actually have children who are raised without a mother. And so when we're thinking about the early mom in those first 3 years, we also have important population subgroups where we can think about diverse family structures, and why not? I also think about surrogates, gestational carriers. Maybe there's something to be informed there. So I haven't heard anything today that makes it sound like this is hard, including the microbiome and into the environmental work of, we have a lot of great epidemiologic tools. We know how to collect data. We know how to measure diet, medications very well. We know how to collect biospecimens, and it seems like the laboratory work is there. So why not? I'm really excited. Thank you.
Thank you very much. My comments, I hope, will be brief. And in terms of I'll deal with the second one. In terms of age, many years ago, William Hansel and colleagues who were interested in the epidemiology of gastric cancer did studies of migrants. And they found that the period of most relevant exposure was young childhood. This is for cancers that developed at age 60, 70, and 80. And there's the work of Jules Hirsch in experimental models of obesity in mice and rats showed that when you overfed animals early in life, they put on more adipose tissue, and it was very difficult for them to lose that. And so I keep coming back to early life as a really important period, not only for risks in childhood, but for lifelong risks. And that's where I would really try to focus. And what I would do in a practical sense, what's wonderful is that there are so many cohorts, and there are new cohorts that are going to be formed. And I think that all the cohorts that are formed have to take microbiome into account and have to bank specimens, whether they're fecal specimens or urine or blood, or ideally all of them. And same thing for clinical trials. The clinical trial is a great structure to understand what's going on biologically. You can really test hypotheses with the clinical trial. It would be unthinkable to do a clinical trial today without banking a blood specimen, and I think that's what it's going to be like for specimens for microbiome. And I think that's it. Thank you.
Well, I'd like to echo what Martin has just said about this early period, and I think he very nicely illustrated this period of prior to age 3 and how the microbiome is not adult-like, and then it stabilizes. So from a public health perspective, that gives us an opportunity to understand what are those environmental factors that drive or potentially perturb that very early period, and that we could have a lifelong impact on a child. I mean, this is an opportunity not to be missed. And we know that early life growth, for example, and the growth trajectory in the first 3 years of life predicts metabolic disease and cardiovascular risk later in life. So I also need to underscore the importance of that. Also, that in order to look at some of these sexual dimorphism factors and these other interactions by delivery mode or feeding mode or antibiotic use, as an epidemiologist, I'm obligated to say that it will require studies of some size. And then looking at the outcomes in our children is going to require us to prospectively follow them for some clinical outcomes, to understand the impact of the early microbiome on the shaping of their outcomes and clinical outcomes and their phenotypes. So those are some of the things to keep in mind. The other approach that we're trying to take is to be, based on the work of my colleagues here, is to take a more holistic approach where we actually sample the moms during gestation, get their rectal swabs, get their vaginal swabs, collect breast milk, skin, try to get, as we've heard from some excellent talks today, and try to get the picture of how this early microbiome is formulating. So I think all good ideas, and that we may be picking up some of these thoughts tomorrow as well.
Thank you. I'm going to pause for a minute to see if, did you guys want to say something, the two of you? Go ahead.
Mariam Gadarzi from Georgetown University. I missed a good part of the morning session, so maybe my comment was already covered by Andrew Patterson's talk, but I've seen a lot of correlative analysis done between the diversity of the microbiome and the metabolomic data. But not much has been done in terms of looking at the relationship or interactions between the microbial metabolome and the host metabolome, which is very important. I know bile acid metabolism was mentioned, and population, certain phyla of bacteria that can particularly affect that mechanism. But it's also interesting or important to keep in mind that probably some microbial metabolites also have an impact on the effects that we're seeing.
Yeah, that was discussed a little bit this morning, but yeah. Anyone want to comment on that? Tamara, did you have anything? Okay. So the one thing I wanted to ask is, Yvonne has left, Yvonne Rusin. He posited this morning that the current study designs that look at environmental stressors and chemicals specifically already capture whatever the contributions the microbiome may be to the effect of those exposures and the health effects of those exposures. First, I wanted to get a reaction and see if generally you agree that for the existing chemicals, we may not know how and why things are happening, but the data that we're collecting already capture the role of the microbiome. I'd like to get some reactions to that.
They only capture it if you know what you're looking for.
Yeah.
It's
Exactly.
like we know that the ocean is full of minerals, but we can't easily get to it because unless we use specific techniques. So you're right, they're there, but then they have to be re-examined and reanalyzed.
Because what struck me, even appreciating what Yvonne was saying, is that in the industrial age, whatever our understanding of the health effects of chemical exposures have been, with the lifestyle changes and the effect on microbiome, the changes in terms of extinction or resilience, the new generation of new babies now have physiologically a very different baseline, it seems, just from the data that everyone presented today, that the changes in the microbiome just due to lifestyle changes alone, on top of the exposures that are out there, means that these interactions, there's just going to be less space for bouncing back. The resilience, it seems to have diminished, and there's evidence of either extinction or sufficient changes in the microbiome that maybe our assessments are going to see or pick up effects that maybe we didn't see in the first 100 years of the industrial age. Is that something we should be looking at or probing?
Well, somebody who likes data, I would like to make sure that we have both the exposures and the microbiome well measured so that we can actually formalize our assumptions and test that.
So it seems like we're starting to have either data on the microbiome or data on the chemicals. So the question here would be, how do we start collecting them in a way that we can evaluate those interactions, I guess?
And I think what is no longer open for discussion is the fact that it can't be done. I mean,
Yeah.
I think the investigators and others who are not in the room have shown and demonstrated that this kind of work can be done.
And what I was thinking myself is that even if that could be true, of course, what we know about the chemicals, their effects or metabolism is reflecting both the host and the microbiome, and at the time we couldn't measure it. But we still want to know what is the relative contribution of each, and we still want to know how with change in microbiome things might be looking different or not. So I think that's going to require some reanalysis of those chemicals, and many of the exposure remain relevant today. So that I think that will need to be done in my understanding. And I mean, it's obvious for arsenic, that has been talked a lot today, but I think it's obvious for many other chemicals.
Couldn't find, besides antibiotics, we had a hard time even putting this workshop together to find a lot of evidence beyond arsenic or just some of the metals in terms of where the data on the metals or on the chemicals have been collected in relation to the microbiome. And I think that's, if we're going to probe this question further, that's what we have to think about, is how do we collect that type of data? Go ahead.
I'd like to offer an umbrella concept here of recovery, which is kind of a missing piece in toxicology. I mean, toxicology is about how you get killed and how you get damaged and so forth. But I think that not only for that itself, as somebody who looks at toxic substances, we're interested in, and others are beginning to be interested in, how does a cell recover? Not assuming it's going to die, actually, that it is going to recover in some wise and be modified perhaps or not. I think that's an important thing to borrow in this context, because there's certainly been a lot of sort of ad hocing over the years with respect to probiotics and prebiotics but we could enlarge our thinking about that in ways that have to do with how do we do more for the host to help the host restore at least an unantibiotic or otherwise assaulted flora from when it was born. We're never going to get back, I think, Marty, we're probably never going to get back to the same flora that Gloria finds in the tribes in the Amazon, and we probably don't want to. But I think that there's the one we start with, at least. It gives us a fair amount of health, and if we have this concept of recovery as part of our intellectual responsibility, I think that's a rich area.
Can
Joel,
I
did
add
you-
a comment?
Oh, yes, go ahead, sorry.
Yeah, I want to add to that comment that in addition to restoring for the well-being of that person living his or her life, restoring women is particularly important because those to-be mothers will be responsible for the future generations' microbiomes and so on. So I think this is a context to take special attention to women's health, especially mothers. And in our society, we have also, I wanted to add to your comment on the challenge of kids being brought without moms. We have in our study a dad who is a mom. So we are living in a complex society. There will be kids that are born to transgender, and that will be more and more common, and those are scenarios that we have to understand the consequences to be able to help.
Joel, did you want to make a comment?
Yeah, so two things. One, in terms of the
Introduce yourself with the phone.
Hi, I'm Joel Schwartz from Harvard University, and I'm a member of the committee. One, it's true that we have studies that have measured the microbiome and studies that have measured exposure and not so much overlap. But there is some overlap, and we do have methods for assessing variability in response to exposures, which we talked about in the last method, so we can get an idea of what's going on there. We have ways of looking at the impact of the microbiome, and we have some studies that have both, and the machine learning algorithms that we heard about earlier today do constitute a way that you can try to put that data together, and without necessarily being able to say this exposure, and this particular flora in the microbiome, but ask the question, how much of the variability in response to certain kinds of exposures has to do with variability in the microbiome? So obviously we'd like to get more detailed stuff, but we could start there. So that's one point. And the second is the interesting comment that was made about the fact that, of course, 100 years ago, microbiome was probably quite different. People probably, responded in different ways to exposure, but, what can we do about that? And I want to point out that about 100 years ago, there was a really bad influenza epidemic. And it particularly hit young people, like, for example, the young people who were on the mines in Svalbard above the Arctic Circle and who got buried in the ice. And people went back and got samples from their lung, and that was how they were able to reproduce the virus from the pandemic. Well, those people also have toenails, right, in which you can measure arsenic, and, their gut got frozen with them. You can probably get, DNA from, the microbiome in the gut. And, there are probably other places besides there, but that's one I know about, where there are bodies that have been frozen at very cold temperatures for a long time, and where you might be able to get some information about, with different diets and different behaviors and lifestyles and stuff, how these things sorted out differently.
Okay, we have a question from the web addressed to the panelists. Have any of the panelists reviewed fetal programming is the question. The role of the microbiome, I guess, in fetal programming. I think that's what they're referring.
If the question is referring to epigenetics, then yes, I mean, we're assessing that in our cohort and as are others, for placental DNA methylation and cord blood methylation, which I mentioned. And we are planning on looking at the relationship between the microbiome and epigenetic profiles. So if that's what they mean, yeah, that is, I think that is an area that is worth exploring.
Yeah, we could have more detail than that.
I just Googled the phrase because I don't know it that well, and it seems, so I think they're referring to the resetting by environmental events of important physiological parameters. I don't know if that helps. I asked for more clarity.
I think Margaret answered here. Sorry.
So Helmut Zarbel. So Tina, I'd like to get back to the question you raised about Yvonne's comment that we're already doing a good job with risk assessment by applying safety factors. Yeah, I'm sure he'll hear. But anyways, the fact that we're already applying safety factors and that's done a pretty good job. But I think we actually heard an example today where that's not going to work anymore. So we heard obesity is an epidemic and it's related to the microbiome, and that's affecting basically asthma, and in particular the response to ozone. So we have an ozone standard. As our population becomes more and more obese, or a larger percentage, is that still valid? I mean, there's an example of where our risk is actually changing as a result of something that we can trace back to the microbiome. So just because we did a good job in the past, and as Joel said, the microbiome is changing, so our risk is going to be changing. So we can't just say we've done a good job and that captures everything. I think that would be a mistake. I think there's an opportunity here that we have these new techniques and these new technologies and new way of thinking, and we need to apply them.
On top of that, there's a lot of epidemiological evidence that seems to challenge whether the current standards are as protective as they need to be, because there are evidence of health outcomes that indicate that some exposures are not they're not benign at those supposed safe levels. And this question, as you're raising it, is maybe because the health status of the population is changing, either due to the microbiome or something else, that there seems to be a need to be vigilant about those evaluations and see if those standards remain relevant, like the ozone standard. I don't know, John Vandermeer, if you want to comment on that.
Oh, come on.
Want to comment on that?
Well, I just wanted to make a comment that related to the point I was making earlier, that the microbiome could be a sentinel sort of outcome or intermediary mechanistic outcome for risk assessment.
So in terms of establishing baselines? Or?
Well, in terms of understanding what the dose of exposure is that might have a clinically relevant impact. Yeah.
Except that we heard today that that's so personal. And to set standards, we have to look at population effects. That's been the challenge in the end to understand is how do you get to the forest, as Linda was asking, which is what we do in standard setting. Do you want to comment?
This has just been a fabulous whole day, and the panel's been very interesting. I just want us to just remember the microbiome and environmental chemicals are just two different kinds of environmental stressors that we have to be thinking about. So we need to think about, somebody mentioned lifestyle, somebody mentioned SES, people have mentioned infectious agents, which all interact. And we really need to get better about putting it all together instead of just looking at one or the other.
I can't help but think, Linda, if Martin Smith or Steve Rappaport were in the room, they would go back to your exposure biology perspective and say, regardless of the stressor, the effect is manifested chemically and biochemically. So what becomes important is to understand what those relevant markers or metabolites are.
I'm not questioning that at
Right.
all, because say the metabolome is going to vary based upon all of this, and I think we're really going to need to be focusing on pattern recognition
Yes.
as opposed to individual changes.
I think it's a lost opportunity if we don't start putting all these different domains together, because I think that's the way we're going to get really good signals about intervention or therapies. And I think that's always a risk if we're only doing one or two. But to be able to put it together, that we may get the new clues there.
I wanted to add a comment. So from the point of view of the microbiome, we have no idea of what functions we may have lost in relation to our evolution until 100 years ago. And on the other hand, all the problems of exposures to chemicals, etc., have arose from our technological capability. And I'm afraid that we will not be able to adapt to the pressures of the cultural evolution. We will not have the time, because we are maladapted basically to the environment we have created. And the problem is the biology takes longer, so we cannot expect that we will have to adapt as biological beings to the pressure of cultural evolution. So therefore, we will not have another option than change the exposures, restore, and just respect who we are, because we are a product of thousands of years of evolution. And I just wanted to leave that there because, again, for me, we may lose the opportunity to study peoples that still live in ancestral environments and understand the impact of our cultural lifestyle.
To end the discussion on today. Did you have any more comments at the microphone? No. No. Did you have any comments that you wanted to make? No, you're okay. If not, I think it might be a good time to try to wrap up for the day. I think this has been a terrific, actually exceeded our expectations. So, Marilee, do you want to say something about tomorrow morning?
Thank you.